Unit 7, Lesson 1, Exponent Laws. So this is a review of grade 9 and grade 10. Okay, so this should be quite easy for you. Couple definitions first. So remember that when you have a base and it's raised to an exponent, that entire thing is referred to as a power. Okay, and if you forget, in this situation, the 4 is the base. Okay, the base is kind of the big number that has the exponent attached to it. Okay, and then the exponent is that small number up in the top right corner. Okay, and just keep in mind that your base could be a constant, so 4, which is in the example there, or your base could be a variable. Okay, likewise, your exponent can be a constant, so just a plain number, or your exponent could be a variable, and that's new. Okay, so we're going to learn how to deal with powers where the exponent is a variable in grade 11. Okay, some quick rules that you would have learned in grade 9. So the product rule tells you how to multiply powers with the same base. So remember, when you're multiplying powers with the same base, you keep the base and you add the exponents. Quotient rule tells us how to divide powers with the same base. So when you're dividing powers with the same base, right, those both have an x as a base, you keep the base and then you subtract the exponents. Thirdly, the power of a power rule tells you how to deal with powers that are raised to another exponent. So we have x to the power of 4 raised to another power of 2. And the way we do that is we keep the base and we multiply the exponents. Okay, don't mix up power of a power rule with product rule. I see that all the time. Okay, and a couple other extras. So when you have a base raised to the exponent 0, so see this, x to the power of 0. Anything to the power of 0 is 1. Remember that. Okay, so even if I had 4 million and I raised it to the power of 0, the answer there is 1. When you have a negative exponent, so for example, 2 to the exponent negative 2. Okay, think of negative exponents as not a good thing. We don't want to have something with a negative exponent. So to eliminate that negative exponent, we take the reciprocal of that term and then the exponent becomes positive. Here's what I mean by that. So 2 to the power of negative 2. To turn that into its reciprocal, we go 1 over 2. And now the exponent becomes positive. Okay, so if ever you see a base raised to a negative exponent, to deal with that, turn it into its reciprocal, or think of it as putting it into a fraction where 1 is the numerator. Okay, and then the exponent is positive. Okay, and the last thing I want to remind you guys is remember those 3 rules, product rule, quotient rule, and power of a power rule, can only be used when you're dealing with powers that have the same base. Okay, so if I had 2 to the power of 3 times 4 to the power of 6, you could not use product rule on that because they do not have the same base. Okay, so that's a review of grade 9 and 10. If you're struggling with that, ask for extra help. The last thing that might not be super familiar is how to distribute an exponent. Okay, so if you have something like this, x, y squared, and that exponent is outside of the brackets, you need to distribute that exponent of 2 to both the x and the y. Okay, so this would become x squared, y squared. Okay, now if it was 3xy all squared, everything inside of the brackets gets that exponent too, even the 3. So this becomes 3 squared, x squared, y squared. And just keep in mind that this distribution only works when we're dealing with multiplication. So we can do this because it's x times y, or because it's 3 times x times y. Okay, that's multiplication. If it was, you know, x plus y all squared, you can't distribute the same way. Okay, it's not equal to x squared plus y squared. Okay, this is only true when you're dealing with multiplication. Okay, and finally, how do we distribute when we have division involved? So that's this example here. Okay, and it's very simple, right? When you have division involved and they're all raised to an exponent outside of the brackets, you just apply that exponent from outside of the brackets to both the numerator and the denominator. So if I had 2 over 3 squared, that's the same as 2 squared over 3 squared. I just distributed that squared to both the numerator and the denominator. All right, so let's try some examples now. So example 1, simplify and then evaluate, okay? Okay, so part A, 2 to the power of 7 times 2 to the power of -4. So because we have exponents with the same base, I can use my product rule. So product rule says keep the base and add the exponents. So this becomes 2 to the power of 3. Now that we've simplified, let's actually evaluate. Okay, so 2 to the power of 3 is 8. Okay, part B, 5 to the power of 10 divided by 5 to the power of 8. So we have the same basis, so let's use our quotient rule. So quotient rule says keep the base and subtract the exponents. Okay, we're going to use quotient rule again on part C. And now that we have a negative exponent, we're going to eliminate that negative exponent by turning this into its reciprocal with a positive exponent. Okay, part D, we're going to use power of a power rule, so we're going to multiply our exponents together. And then we're going to eliminate that negative exponent by turning this into the reciprocal with a positive exponent. And we get 1 over 9. Okay, so those ones are pretty basic. Let's get into some more involved questions. Okay, so first thing I'm going to do here is I'm going to distribute the power of 2 that's outside the brackets to everything inside of the brackets because it's multiplication, so I can do that. So it's going to be distributed to the 3, the x, and the y. Okay, now I'm going to multiply these two terms together. Okay, so I'm going to multiply the pieces that have the same base. Okay, so obviously start by multiplying your coefficients. So 9 times -2 is -18. X squared times x squared is x to the power of 4. And y squared times y to the power of 1 is y to the power of 3. Remember, when there's no exponent written, it's just an exponent of 1. Okay, let's distribute the 4 to everything inside of the brackets because it's multiplication, so we can do that. Okay, and now I'm going to take my x to the power of -4 and turn it into the reciprocal with the positive exponent. Okay, now I'm just going to clean this up a bit. And there's our final answer. Okay, so part C, we have a term inside of a set of brackets raised to the power of -2. Right away, I'm going to get rid of that negative exponent by putting the question to its reciprocal form, and as such, -2 will turn into a +2. Okay, now I'm going to distribute that 2 to everything inside of the brackets because it's multiplication. When I distribute it to the x to the power of -1, I'm going to use power of a power rule because the x already has an exponent. Okay, now our x term has a negative exponent, so let's turn that into its reciprocal. Okay, and remember, when we're dividing by a fraction, that's the same as multiplying by its reciprocal. So this actually turns into x squared over 4y squared. Okay, part D, the first thing I'm going to do is I'm going to clean up the denominator. So I'm going to multiply 9xy squared times 2xy. Okay, now I'm going to go ahead and simplify using the quotient rule. So first let's simplify 27 over 18. Okay, so both of those numbers can be divided by 9, so let's reduce that fraction. Now let's use the quotient rule to divide x to the power of 3 divided by x to the power of 2. So we subtract those exponents and we just get x to the power of 1. Now let's divide y to the power of 1 divided by y to the power of 3. So we'll use our quotient rule on that and we'll subtract the exponents. We get y to the power of -2. Now let's just simplify this by eliminating that negative exponent, okay, that the y is raised to. So to do that, it's going to become 1 over y squared. And then that's the same as 3x over 2y squared. Okay, part E, let's simplify the numerator first. So we have to distribute the power of 2 to everything inside of the brackets. So it's going to become 25. And then we need to multiply a plus 1 times 2, because that's the power of the power rule, right? A plus 1 is the first exponent, and it's raised to the other exponent of 2. So the power of a power rule says when you have an exponent raised to another exponent, multiply them. Okay, now in our denominator, we're going to use our product rule because we're multiplying two powers with the same base. So it's going to be keep the base, and then we're going to add the two exponents together. Okay, now let's simplify those exponents in both the numerator and the denominator. Okay, now the last thing we want to do is we want to divide x to the power of 2x plus 2 by x to the power of 3a minus 8. And just one little mistake. My x's should be a's. Okay, so to divide the two powers with the base x, we're going to use the quotient rule. We're going to subtract their exponents. So we're going to have 25. And now let's go ahead and apply the quotient rule. So we keep our base and we subtract the exponents. So 2a plus 2 subtract 3a minus 8. Now let's just simplify that. Okay, so if you wanted to simplify this a little bit further to eliminate the negative exponent, you could factor out a -1 from the exponent, so that the entire exponent is deemed as negative. Okay, now we could turn that into its reciprocal in order to get rid of that negative exponent. Okay, so hopefully the first page was very easy for you, and the second page was a little bit more tricky but still doable, okay? If you're struggling with any of this, please let me know. It's important that you're confident working with these exponent rules as we move to the later parts of this unit.